Hey guys, Miss Kulkarni here. So in this video, we will talk about chemistry of alcohols, and our focus is going to be on structural isomers. So we will talk about few things. One of the thing is what are structural isomers. Then we also need to understand how to identify and name each of the isomer of the alcohol if we had been given a 3D model picture which is different than just having a formula given to you. Then we also need to identify the nature of alcohol. Mainly, is it primary, secondary or tertiary alcohol? Because that will decide how is going to react. So we'll review some reactions and then we'll apply all those principles. So let's begin with actually taking a question from exam. In this typical question, what is given to you? There is molecular formula given, and we know of course it's an alcohol. We need to find out the name of each of the molecule. When there is a 3D structure given, sometimes it's hard to understand what the structure is, which is carbon, which is hydrogen. So just use that key which is given to you and write down the structure. For example, this group here is carbon attached to all hydrogen. That means it is CH3. These two groups, if you see clearly, that is carbon and then two hydrogen, so it's CH2. This is same CH2, and this, the darker color sphere, is oxygen, so this group must be OH. So let's write down the formula here properly. That's our CH2OH, and then that's connected to this carbon which is CH2. Then we come back to this carbon which is CH2, and we come back to the CH3 group here. That was simple. Now let's do the same thing with all the molecules. So over here, this is CH3. This one is, if you look carefully, is one hydrogen, and then this is OH group. Over here, this is going to be CH2, and the last part of course is CH3. Now let's come to the molecule C, and this is the part which is OH. This is our carbon. So we got all the other groups which we have are methyl groups, CH3. So the structure will be carbon connected to 3 methyl groups and OH group over here. And let's do one more. This one is, of course, these two are CH3 groups. If you look carefully, this is OH, and this part is going to be CH2. So what do we get? CH2, that is OH, and then we come back to the second carbon here, and then what we have is CH3, CH3, and don't forget there is a hydrogen right there. Now let's start naming the alcohols, and I hope you remember the naming rules of alcohols which we discussed in one of the earlier videos. So number one is we need to look for the longest carbon chain, and there you go. If you look at the first one, it's 4 carbon atom. That means it is butane. And since we have alcohol, it's going to be butanol. Before that, we have to make sure how we number. And the functional group should get the least number. So what we have here is 1. That means it will be butan 1-OL. Or we can also simply say 1-butanol, indicating that we have alcohol with 4 carbon atoms and the alcohol group is at position number 1. Let's move on to molecule B, and if you number it 1, 2, 3, 4, again is going to be butanol, but look carefully. At position 2, we are getting the alcohol. So it will be butane 2OL, or we can say it's 2-butanol, indicating that at position 2 we got OH group. Now let's turn to molecule C, and this is kind of interesting. Whichever way you go, it's going to be 3 carbon atoms. That means it is propanol, because it is an alcohol. And numbering, whichever way you go, still the OH group comes to carbon number 2. So it is going to be 2-propanol, but we also got one more group there at position 2. So it is 2-methyl, and then we can say propan-2OL, or we can also say 2-methyl-2-propanol. And finally moving to molecule D. So again, I'm going to number it 1, 2, and this will be 3 if I go in this order. So it is still going to be propanol. At position 1, we got OH group, and look carefully, at position 2, we got methyl group. So this is similar to what we got at C, but the OH group is not at position 2, at only at position 1. So the difference will be 2-methyl, and it will be propan 1OL, or it can be also 2-methyl-1-propanol. So all these 4 molecules are structural isomers of alcohols. The molecular formula is still same, only the structural formula is different. Just imagine they all have different seating charts, and carbon, hydrogen, and oxygen are placed at different position. Now that does make a difference when we think about reactions. They're not going to react exactly same. We will talk mostly about the reactions for oxidations for all these alcohols. Number 1, we have to make sure we know the conditions which are required. Oxidation is different than combustion, so don't get confused. We are not going to have O2 as a reactant. How does it work? It's always alcohol reacted with acidified potassium dichromate. So we use potassium dichromate, and we need to have acid. HCl is something which can work. We can also write down as H plus ion, indicating is the acidic medium. And then we get the product for each of the alcohol. Now, when we say each of the alcohol, not every type of alcohol is going to react exactly same way. We need to know if your alcohol is primary or secondary or tertiary. And we already discussed that in previous video. If you don't remember, go and check it. So let me write down the formulas for all the alcohols one by one here and go over with the products. So there it is. Now let's find out for each of the molecule if it is primary, secondary or tertiary, and then predict the products. So for alcohol molecule A, what we have there is CH2OH. What does it make? That makes the group as primary alcohol. And what happens to primary alcohol? We discussed again this in our reactions video for alcohols. So primary alcohol goes through 2 stages, and we get everything else same except that alcohol group is converted to an aldehyde group first. And if you continue it further, then we get that aldehyde group converted to an acid group. So that will be our final destination product if we continue the oxidation. And this will be the intermediate product if we stop in between. What about molecule B? Molecule B has a group CHOH. What do you think it is? It is going to be a secondary alcohol. And if you remember from the video, secondary alcohol gives rise to Of course, a ketone. So we're going to get everything else remaining same, and that alcohol group is going to be converted to ketone. And that's it. It stops there. No further oxidation. Let's look at our molecule C now. And if you look at that, it's only going to be COH. There are no hydrogen directly linked to that carbon. What does it make? It becomes tertiary alcohol. And tertiary alcohol are just like stubborn people. So that will not react. So there is no reaction at all. With oxidation reaction, that's it, full stop. And finally, the molecule D, the structural isomer of alcohol, which is the form D. If you look at only the alcohol group, it is still CH2OH. That means it will be primary alcohol. So, as we discussed, similar to our molecule A, this is the part which will be changing. Everything else remains same. And we are going to get that as an aldehyde. And if we continue the oxidation reactions further, then we get that aldehyde group converted to the carboxylic acid. So now you know the naming of structural isomers and how each alcohol can be identified as primary, secondary or tertiary, and how they're going to react. So if your exam questions is a mix and match of questions like this, you should be able to answer all of those. First question is, which isomers could not be oxidized? Always keep an eye. If suppose says could not be oxidized by acidified potassium dichromate. If you remember, we only got one type of alcohol and we said no reaction. It was alcohol C, and because that was tertiary alcohol. Next question is, which isomer could be oxidized to butanol? That is the aldehyde. And we have two alcohols which could go to aldehyde unless we stop the further oxidation. And those were alcohols A and D. Moving on to next one. Which isomer could be oxidized to butanone? Oh, that is the ketone. And there was only one alcohol which could be oxidized to a ketone. Which was that? That was alcohol B. Let's do one more quick thing. If you had been given the molecular formula, but now I'm saying that write down structural isomers for any other type of compound. That means it may not be alcohol. It could be anything else. Again, it's a question of change of seating chart. So one other thing which comes to my mind is, if I want to look at the groups, I can have probably CH3O, and I need to make sure I got 4 carbon atoms. And I believe that should give me the same molecular formula. That is your one formula. Can you write down the other formulas? I'm waiting. So there should be 2 more structural formulas if I am not limiting this molecular formula to an alcohol. Okay, did you get it? Well, if you already got it, check the answers. We can have a symmetrical ether, diethyl ether, that's what we call this. And how about the third one? This is a little tricky. I am actually going to branch this chain of carbon atoms. And you know what? Organic chemistry is like this. You have to be creative and you should be always willing to learn something more. So there it is. And here is a question for some more brain work. If you are going to synthesize, let's say isomer A, and what is given to you is the starting material is 1-bromobutane. How would you synthesize that? So did you get the answer? Well, let's make it easier. So that's 1-bromobutane, and you can begin writing 1 from either side. I just thought let's make it comparable to what we wrote, that is your 1-bromobutane. And you need to come up with the reaction strategy by which we are going to convert this to OH, because that's our molecule A. Does it ring the bell? Well, let me give you one more clue. Both these bromide and OH are called as what? They are called as nucleophiles. So, what could be this? This is nucleophilic substitution. And how do you get that OH? Usually it is added by aqueous sodium hydroxide. And there are different pathways for nucleophilic reactions. If you need to know more, watch the next video. So guys, I hope you enjoyed the video and I will see you again in next video. Until then, bye bye.